Okay, just as a little starter today, I would like you to have a go at answering this question at the Olympic Games. So, at the Olympic Games, New Zealand has one competitor in each of the 100 metres backstroke, freestyle, butterfly. The probability that each swimmer makes the final is in the table. Draw a tree diagram with the probabilities for all outcomes. What is the probability that there will be exactly 2 New Zealanders in the final? Right, pause the video, draw that up and get an answer, and then press play again. So we've got our, hopefully you had a go at that. We've got our 3 answers here: backstroke, freestyle, breaststroke. We've got that whether they make the final or not. So the complement, make the final, complement for backstroke and freestyle, breaststroke. And then we can work out the complements of all the probabilities then. Multiply along the branches to find their individual probabilities. Find the ones that have exactly 2 New Zealanders in the final. So backstroke freestyle finalists. Then we've got backstroke breaststroke finalists. Then we've got the freestyle breaststroke finalists. Add those together and we should end up with 0.07712. So hopefully that's the answer you got. So today's lesson is looking at something called risk. There is a worksheet that accompanies this video and the PowerPoint. If you can, it would be great if you could go back to the lesson page, print that off, and as we're going through this, pause the video, filling in the gaps as we're going along. So if you can do that now, that'd be great. Okay, so we've got a couple of short videos to look at. And this first video is introducing this idea of risk.
Hello, my name's David Spiegelhalter. I'm the Winton Professor of the Public Understanding of Risk here at the University of Cambridge. I started off as a mathematician, but I've recently become much more interested in how to use maths and probability in the real world, in particular for dealing with risk. Now, by risk, I mean everything where we don't know what's going to happen. So we might be talking about lotteries, we might be talking about predicting football results, or we might be talking about what is generally known as risk. For example, what's the dangers of riding a motorbike or taking illegal drugs or whatever. And of course, the newspapers are always full up with stories about all these things that are bad for us. How we eat, how we live our lives, and how we can try to improve our health and make us live longer. And there's usually maths, almost always there's statistics and numbers behind these stories. And what I'm interested in is trying to take those stories apart, to look at what's in the newspapers, to take them apart, and to use what's actually quite some very useful but fairly basic maths to do with percentages and numbers, to try to understand what's really going on and whether there are things we should be worried about or not.
So obviously that's quite topical at the moment with looking at COVID-19 and the risks associated with that. And in a way, risk is just simply looking at the chance of an event occurring that has usually some sort of bad connotation to it. So what's the risk of getting a virus, or what's the risk of catching the virus if you meet in large groups, all those sorts of things. And it's so really the process of us talking about risk, all we're wanting to do is be able to compare probabilities and how much of more of a risk are certain things, and make decisions based around those statistics. So what is the risk of getting... so here's an example. We've got 200 young drivers without a full license. So they either have a restricted or learners. So you assume that young drivers would have at least a restricted or a learners without driving. So that's why there's no other grouping. And it's whether they got a traffic infringement. So the first question we'll go, what is the risk of getting a traffic infringement? So, well, that's the total. So that's out of 200. So that's the 23. So it's of all the people, of the restricted drivers and the learner drivers together that get a traffic infringement out of the 200. Now, then if we talk about the risk of just the restricted drivers, it's that conditional probability. So rather than it being out of 200 now, it's out of 100 because there are 100 restricted drivers. So 23 out of 100, so 0.23. So what is the risk of getting a traffic infringement if you're a learner driver? Well, that's 56 out of 100 because it's not out of 200 because we've given that condition about it being a learner driver. So what we can see straight away is that you're actually comparing these numbers is that 0.56 is twice 0.23. So you're twice as likely to get a traffic infringement on your learners than what you are in the restricted, which kind of makes sense that you're a less experienced driver, more likely to take risks, all those sorts of things. So risk is related to the context. What is the risk of a person with a traffic infringement being a learner driver? What is the risk of a group having something happen is how we tend to phrase it. Risk is usually associated with something detrimental, cancer, death, food poisoning. Never tends to be, when we talk about risk, it never tends to be a particularly nice topic. There's also economic risk, business risk, as well as health risk. And also risk can be presented as a ratio. Quite commonly, the risk of being struck by lightning is 4.5 per 1 million people. So the risk is actually a really small number. So we tend to give it as a ratio if it's a particularly small probability. Okay, so there's another one of these videos talking about the different types of risk, how it's presented, and some of the things that people can get caught out by using risk as a statistic.
I'd like to give you an example of how we can take apart a risk story in the news. A little while ago, it was reported that people who ate a bacon sandwich every day, here's not a very good picture of a bacon sandwich. People who ate a bacon sandwich every day had a 20% increased risk of getting bowel cancer during their life. Now, bowel cancer is a pretty horrible thing, and so a 20% increased risk sounds very serious. Now, let's think about, what does that mean, though? Is this something we should be worried about? Okay, so one of the things we need to do in order to work out whether we should be worried about this or not is to know what the actual risk of getting bowel cancer is if we don't eat bacon sandwiches. And it turns out that about 1 in 18, that's about 5% of us, are going to get bowel cancer at some time in our lives. It's very, very sad, but it happens. So it's about 5%. Now, this all starts getting complicated because we've got 5% of people getting bowel cancer. We've got a 20% increased risk from eating bacon sandwiches. We've got percentages of percentages. This gets really tricky to think about, and I can get very confused very quickly indeed. So the trick that people use to think about these things is to try to actually get away from percentages, get away and not use decimals or anything like that, but just think in terms of whole numbers, what's called natural frequencies. And actually think of what would happen to 100 people. So here's my 100 people. These 100 people who are just sort of normal, healthy people. And it turns out, though, using the statistics that we found out, that 5% of them, that's 5 of them out of the 100, are going to get bowel cancer, sadly, at some point in their lives, even if they don't eat bacon sandwiches. So let's say, it could be that one. We don't know which 5 it's going to be. 1, 2, 3, 4, 5. Now, it's sad, they will get bowel cancer at some point in their lives. We don't know who they're going to be, but 5 out of 100. Now, what happens if all these 100 people had eaten a bacon sandwich every day for their whole lives? Okay, so what the story in the news said is that the risk of getting bowel cancer is increased by 20%. That's a 1/5 extra risk. That means instead of 5 people, the risk goes up by 1/5, which means that an extra person will get bowel cancer. So here we got this one now, whoa, is going to get bowel cancer because they all ate bacon sandwiches. So the effect, if 100 people ate a bacon sandwich every day for their life, is that 1 extra will get bowel cancer. Now, that's very sad, very unfortunate. However, now you might say, well, this doesn't look quite so bad after all. You know, everybody eating all this big greasy bacon sandwich every day, and you were just getting 1 extra. So out of 100 people, only 1 is getting the consequences. Now, of course, they may get fat and all sorts of other stuff as well, but actually for getting bowel cancer, only 1 in 100 of the people eating the bacon sandwiches is going to suffer because of eating the bacon sandwich. So by doing it this way, we've done a 20% increase of a 5%, what's called an absolute risk. So, okay, here's some words, some technical words. We call the 20% increase a relative risk because it's relative to what the risk was before. And the risk before was 5%, and that's known as an absolute risk because it's the actual proportion of the whole group of people. Now, you know, those are some technical words, but quite useful, and they're really important to distinguish. The fact that the relative risk is 20% sounds quite big, but when the absolute risk is quite low, it turns out that actually we might not be too worried. So what it means is that I haven't given up eating bacon sandwiches. I only have about 1 a week, probably, so I don't eat 1 a day. But, you know, this is not going to have a big effect on my life. But maybe you feel differently.
So the key thing from the video was talking about the difference between relative risk and absolute risk. So, and the point it's trying to make, if you have a large percentage increase or a large percentage difference of something that's very unlikely to happen, the actual change is very, very subtle. It's very, very small. So as an example, we can have a look. We've got this. I've got a table here of 2 different groups. One's looking at it's split between. Sorry, they're both looking at heart disease. One group that's looking at being overweight, and the other group is about smoking, whether people smoke or not. So obviously the absolute risk ignores the risk factor. So the absolute risk of getting heart disease in group A is looking at 38 out of 350. Now with group B, okay, you can see that it's 21 out of 170, so slightly more, but if we're talking, it's 2% more. So with the size of the groups, that's actually reasonable. They look roughly the same. Now, the risk of heart disease when you are an overweight male is 0.145. So that's starting to get a little bit higher. Now, smoking gives you 16%. So that's quite a large increase. And you could say that when you compare these 2 probabilities, that you're more likely to get, a smoking male is more likely to get heart disease than an overweight male. So you could argue to say that being overweight is less dangerous than smoking for heart disease. Now, it could be that there's other things that are more likely to happen if you're overweight and all those sorts of things, but certainly for heart disease, the statistics are showing that the chance of you getting heart disease if you smoke is higher than if you're overweight. And if we compare that to someone who doesn't smoke, which we end up with a probability of almost half as much. So they're the probabilities that it's probably more sensible to talk about. If we were talking about a sensational headline, we could talk about the fact that you are 80% more likely to get heart disease from smoking than you are if you weren't smoking, and whether that would be a true representation or not. So conclusions, what do you notice? You're more likely to have heart disease if you smoke. How can you compare risk factors? Overweight males have a 2% less chances than smoking males of getting heart disease. So we talked about relative risk. So relative risk is when you compare them together. So the key calculation here is you take the risk for the exposed group, divide that from the non-exposed group. So based on the study, overweight men are 1.9 times more likely to suffer heart disease than non-overweight men. So to work that out, we would go the probability for getting heart disease if you are overweight divided by the probability of getting heart disease if you're not overweight, which is there. Again, relative risk of heart disease in a smoking male compared to non-smoking male. So smoking male, non-smoking male is 1.7, so you're 1.7 times more likely to suffer from heart disease than a non-overweight male. Oh. Okay, this one last video with the doctor.
As I said, one of my favourite occupations is taking apart risk stories that appear in the newspapers using some fairly basic maths. So here's some examples of things that have appeared recently. 20,000 children put at risk from touching animals at farms. Sunbeds lethal as cigarettes. Is that really the case? Oh, here's an interesting one. Sex cuts cancer risk, but only if you're over 50. An extraordinary story there. And here's one. Here's one relevant to me in particular. New statin cuts heart risk for everybody. Now, statins are drugs that you can take to reduce your cholesterol, and that reduces your risk of a heart attack or stroke over the next 10 years. And this newspaper story says that if I, for example, were to take one of these drugs every day for the next 10 years, my risk of a heart attack or stroke might be reduced by 40%. Okay, now, should I take the drug? How do I start thinking about whether I should take that drug or not? And the crucial thing is to realize that is a relative risk, what's called a relative risk reduction, and whether I should take the drug or not depends on what my absolute risk is. Is this 40% important or not? There's no way of knowing unless I know what's my baseline risk? What would be my risk if I didn't take this drug? Now, it turns out I can put my age and my blood pressure and all this other stuff into a computer program, and it will tell me that my risk, if I don't do anything, of having a heart attack or stroke in the next 10 years is around about 10%, 1 in 10 chance. It's a bit worrying, but, I'm old, so, that's the way it goes. Now, so that 10% risk could be reduced by 40% if I took this drug every day. Now, again, we've got percentages of percentages. This all gets quite tricky. The way to think about it, as we talked about before, is think of 100 people like me. Okay, there's 100 me's. Think of them, 100 me's all in a row. Now, in 10 years' time, if we don't do anything, 10 of these me's are going to have a heart attack or stroke in the next 10 years. That's 10%. But if all of these people, all these 100 people like me, took this drug every day, that would be reduced by 40%. That means that 10 would be reduced to 6. 40% off 10 leaves 6. So that means that out of 100 people like me, instead of 10, 6 would have a heart attack or stroke. That's a reduction of 4. Another way of thinking about that is that 1 in 25, that's 4 out of 100 of people like me taking this drug every day will benefit from taking the drug. 24 out of 25 won't benefit from taking the drug. Should I take it? Well, actually, I can't decide, to be honest. I still don't know. I don't know if I should or not. Because, you've got to take the drug every day. It's got some side effects. It's going to cost, actually won't cost me any money because I'll get it under the National Health Service. But, so I'm still dithering around about this. So the point about this analysis, it doesn't tell you what to do, but it does give you the information that it should enable you to make a reasonable decision on the basis of the evidence. And just reading that something's got a 40% reduction doesn't tell you, isn't the whole evidence, is not the whole story, it's only half the story. So, so I've done those calculations just in my head, and it's to show really that you can take a news story and using some pretty basic but very important maths, and particularly using this idea of what would happen to 100 people, you can actually work out whether these risks are important, whether these benefits of drugs are important, and whether you think, for you or for me, it's actually worth acting, doing something about it.
Excellent. So, so the key things to take out of today's lesson was looking at risk, trying to reduce these probabilities down into 100 people, and trying to work your way through the relative risk, or using the percentages of probabilities to gauge actually how big some of these values are. So in your OneNote, there is a lesson on the lesson page. There's obviously some questions you need to complete. Key thing is the probabilities. Working out the probabilities is no different from what we've done previously. The only difference then is we're actually using them to compare to each other, or in the case of relative risk, you're trying to use a proportion of each other or dividing them. Okay, so make a start on the lesson now.